In this case, we are going to find the confidence interval for the population variance sigma square, and mean is not known. So how we proceed for this one? Let x1, x2 up to xn be the random sample drawn from the normal distribution with mean theta and variance sigma square, where theta is not known and n could be any positive integer. So the condition on the sample size is nothing, you just take any n of the desired problem. We know that if x1 up to xn are the IID random sample from the normal distribution, and s square is the independent is the variance of the random sample, then the random variable y, we define a variable y that is actually the n minus 1 s square over sigma square, and it follows the chi square with n minus 1 degree of freedom. ये भी हम पहले रिजल्ट प्रूव कर चुके हैं कि अगर हमारे पास अन कीपिंग इन व्यू दैट ये रिजल्ट उस सूरत में होल्ड करेगा जब हमारे पास जो एस स्क्वायर है और थीटा जो है ये इंडिपेंडेंट होंगे. ये हम भी शुरू के इब्तदाई मॉड्यूल्स में हम ये भी बात प्रूव कर चुके हैं कि अगर थीटा विच इज़ रिप्रेजेंटिंग द मीन, एक्चुअली थीटा और एस स्क्वायर इंडिपेंडेंट हो तो ये जो वाई वेरिएबल हमारे पास है n माइनस 1 एस स्क्वायर और सिग्मा स्क्वायर ये काई स्क्वायर को फॉलो करता है विद n माइनस 1 डिग्री ऑफ फ्रीडम. ये हमने शुरू के मॉड्यूल्स में इसको भी प्रूव किया हुआ है. तो वी जस्ट यूज दिस रिजल्ट बिकॉज वी आर गोइंग टू कंस्ट्रक्ट द confidence interval for the sigma square, and we do not know about anything the mean, so we consider y variable that is n minus 1 s square over sigma square. So the same thing that the condition which I just mentioned, that theta and say s square are the independent. The random variable y actually here playing as a pivotal random variable, role of the pivot random variable, and using the definition again, that is the chi square p n, the 1 minus alpha confidence interval for y can be constructed as, so we can construct the confidence interval as that is the probability, because here it is follow the chi square, and with this is the lower limit, so that is 1 minus alpha by 2 with n minus 1 degree of freedom less than or equal to y less than or equal to chi square with alpha by 2 and n minus 1 degree of freedom, and that is equal to 1 minus alpha. So we can put the value of the y here, that is probability chi square 1 minus alpha by 2 with n minus 1 degree of freedom, and that is actually n minus 1 s square over sigma square, and that is less than or equal to chi square alpha by 2 into n minus 1 with 1 minus alpha condition. So solving this, जब हम sigma square को ऊपर लाएंगे क्योंकि we are actually going to construct the confidence interval for the sigma square. sigma square population variance के लिए हम confidence interval construct कर रहे हैं, तो जब हम इसको ऊपर लेके जाएंगे तो ये जो inequalities हैं ये हमारे पास रिवर्ट हो जाएंगी, क्योंकि जब हम इसको ऊपर लेके जाएंगे तो ये नीचे आ जाएंगे अल्फा जो काई स्क्वायर विद अल्फा ओवर 2 एंड n माइनस 1, ये जब इसको नीचे लेके जाएंगे तो ये हमारे पास रिवर्ट हो जाएंगी कंडीशंस. तो जो हमारे पास कॉन्फिडेंस इंटरवल बनेगा ऐसी सूरत में, दैट इज़ बेसिकली n माइनस 1 s square, and this will be chi square alpha by 2 with n minus 1 degree of freedom less than or equal to sigma square less than or equal to n minus 1 s square over chi square with 1 minus alpha over 2 with n minus 1 degree of freedom, and that is actually 1 minus alpha. So that is actually the general form of the confidence interval for the population variance sigma square when the mean is not known, and actually it follows the chi square distribution, and that is the confidence interval. These are the limits of the confidence intervals for the population variance.